Hi Year 9, this is our second lesson for the topic of trigonometry. In this lesson we're going to learn how to find an unknown side. So last lesson we learnt about the trig ratios and we learnt that sine theta is defined as the opposite side over the hypotenuse, cos theta is defined as the adjacent side over the hypotenuse, and tan theta is defined as the opposite side over the adjacent side. Now, it could be quite difficult to remember those ratios, so we use the acronym Socatoa to remember it. This is what it stands for. Sine is opposite on hypotenuse, cos is adjacent on hypotenuse, tan is opposite on adjacent. Now, order is important in trigonometry, so I want to really stress that this is what it means. Sine is opposite on hypotenuse, cos is adjacent on hypotenuse, tan is opposite on adjacent. Okay, let's see how we answer a question. Find the value of x. Now the first thing that we're going to do is label the sides, and we're always going to start with the hypotenuse. So we locate the right angle, and opposite the right angle is the hypotenuse. Next we find the angle, which is here. Opposite that angle is the opposite side. And next to that angle is the adjacent side. Okay, we've labelled the sides. Then we write down Socatoa. Now I've highlighted the sides that we have. So can you see that I have got pronumerals or numbers written on the hypotenuse and the adjacent side, but nothing written on the opposite side? So that means we're going to use cos. I can't use sine because we don't have the opposite side. I can't use tan for the same reason. So the trig ratio I want to use is cos, and I'm going to follow this like it's a formula. Cos of the angle, cos 32, is equal to the adjacent side, which is x, over or divided by the hypotenuse, which is 12. There's our equation. Now if you can get that far, the rest is easy because that's an easy equation to solve. We want to get x by itself. We have a divided by 12 that we need to get rid of, so I'm going to take it over the other side. The opposite operation of divide by is times, so it's coming over as a times by 12. Now it's really important that you put this out the front of the trig ratio. It doesn't multiply with the angle. So I'm going to rewrite this. X is equal to 12 times cos 32. Now all I have to do is put it into the calculator. So our answer is 10.2. Now with all the questions in this video, I've decided just to give the answer to one decimal place. Let's try another one. All right, locate the hypotenuse, so it's opposite the right angle, so it's there. Here's my angle. This side here is opposite, and this side here is adjacent. We'll write down Socatoa. I've highlighted the ones we've got, which is O and A. Can you see that this one is going to be tan? Let's follow the formula. Tan 42 equals the opposite side, which is x, divided by the adjacent side, which is 11.5. Again, I've got a very simple equation to solve. I need to get rid of this divide by 11.5. I'm going to take it over the other side as its opposite operation. And I'm going to end up with x is equal to 11.5 times tan 42 into the calculator gives me 10.4. Okay, this one's slightly more difficult because we've got degrees and minutes, but we've already learned how to do that. So start the same way, locate the hypotenuse. Here it is. Here's my angle. Opposite, the angle is the opposite side, and then next to the angle is the adjacent side. Write down Socatoa. What do we have here? We've got O and H. This time we have sine. Follow the formula. Sine 58 degrees 11 minutes is equal to y divided by 4.5. Very similar to the last one. Very simple equation. Get rid of the divide by 4.5. It comes over as a times. And so y is equal to 4.5 times sine 58 degrees 11 minutes. Use your degrees, minutes, seconds button and you will end up with 3.8. Now sometimes the pronumerals can end up on the denominator, like in this question. We're going to follow the same method though. Firstly, locate the hypotenuse. There it is. Highlight the angle. Opposite the angle is the opposite side. And this guy here would be adjacent. Now I've got O and H. Without writing down Socatoa, can you tell which trig ratio it is? It's the first one, isn't it? Socatoa. So it's sine. So we've got sine 32 is opposite, which is 15, over hypotenuse, which is x. Can you see how the x ended up on the denominator? That's why it's so important that you follow Socatoa in order. All right, we've got a slightly more difficult equation to solve. Now, the shortcut to this is that these two swap places. So x is equal to 15 divided by sine 32. But let's do it the long way to begin with. I'm going to get rid of this divide by x. It's going to come over as a times by x. So x times sine 32 is equal to 15. Then I've got to get rid of the sine 32. It's a times by. It's coming over as a divide. And I end up with that. Now have a look. Remember I said we could just swap the places? So sine 32 and x, see they've swapped? So you can use that shortcut if you like. Now it's just a matter of putting it into the calculator. 15 divided by sine 32 gives me 28.3. Now this time we've actually got some units, so we should put those in. 28.3 meters. Let's try one more. So find the value of y. So this time we've got degrees and minutes. Let's label the sides. Opposite the right angle is the hypotenuse. Locate the angle. Opposite the angle is the opposite side. Next to the angle is the adjacent side. So we've got O and A. Can you tell which ratio that is? Socatoa. It's tan. All right, let's follow that. Tan 51 degrees 50 minutes is equal to the opposite side, which is 12, divided by the adjacent side, which is y. There is our equation. Let's use the shortcut this time. So we're going to switch the y and the tan 51 degrees 50 minutes. So y is equal to 12 divided by tan 51 degrees 50 minutes. You can use your fraction button if you want to, or the divide by button. Either way, we're going to end up with 9.4. So let's recap. When asked to find an unknown side, firstly we label the sides of the triangle, and we use that to decide which trig ratio we're going to use. Then we write an equation, and then we solve the equation. Okay, that's the end of this lesson. In our next lesson, we'll learn how to find an unknown angle in a right-angled triangle.